So in my time at ISB, the projects that I worked on generally, again, were with the Baliga Lab, and I worked on finding new ways to tackle antibiotic resistance, specifically with regards to tuberculosis. And so, the main issue that we have is that we just keep generating more and more antibiotics to help alleviate the issue of tuberculosis and try and make treatment actually work for the disease. But unfortunately, we just see that the more antibiotics we get, the more antibiotics actually are no longer working against TB because antibiotic resistance develops. And so rather than creating a new drug, I worked instead with the lab to um, optimize and understand the mechanics behind how resistance develops. In this, I performed something that's known as selective evolution, where basically we selected for the environments which would allow resistance to develop, using lower concentrations of drugs, until the bacteria actually develop this condition where they have resistance to whatever drug I was working with in the experiments. And this was done in a cyclic manner. So we could have a giant timeline of basically what was happening as resistance developed in the bacteria. This is really cool because unlike other systems, you don't really get the opportunity to look at evolution on such a short time scale, but in bacteria, you do get the opportunity to do so. And so through this evolution, I could actually go back and look at different stages in the process of me selecting for antibiotic resistance and see if there were any changes which were indicative of resistance developing or different from the normal cultures or the normal fully susceptible bacteria. And from there, we could then try and understand what processes the bacteria are going through, as well as what changes they were making and what sort of decisions that they were making as they developed this characteristic. And so, in trying to understand these stepwise changes, it gives us a better opportunity to see the resolution of how resistance happens in the first place. And then once we understand that at a very small resolution, we can actually move forward and say we can pinpoint this one aspect of this process to target to completely prevent resistance in the first place. And then that would eliminate the need for us to make new drugs anyway.